Morning, Ron.
Good morning, sir.
Let's start today's lecture. I shared the screen. Is my screen is visible to you? Say yes or no.
Yes, sir.
Okay. So let's start with numericals. We saw the theory part of MOSFET and FET in the previous lecture. So directly we will start the numericals here. So in the question they have given, in case of junction field effect transistor, the value of ID is 5 milliamps. The value of IDSS, the drain to source saturation current, they gave us 10 milliamps. They also gave us VGS offset is equals to minus 6 volt. And they said that find out the value of VGS. Okay, as you know, the formula for the drain current is ID is equals to IDSS 1 minus VGS divided by VGS at offset, you can say, or also you can say pinch off VP whole square. Okay, so in this formula, either you can put VP or you can put VGS offset. Both are same thing. Okay, so if it is given offset, you can assume this is VP, and then you can use the formula IDSS 1 minus VGS divided by VP whole square. Okay. Now you have ID, you have IDSS, VP also is there. Can you find out the value of VGS? So ID is given is 5 milli. It is 10 milli. 1 minus VGS, you have to find out. VP, for example, is minus 6. Okay. So now you find out the value of VGS from here and tell me. Anyone?
18 volts.
18 volts. Let's see. See, it's 1 by 2 means 5 and 10. So it's 1 by 2 is equals to 1 by 4. It will come. So 1 minus VGS, it will be plus 10. Then it will be 6. Then it is square. Then it will bring this side under root of this. So you will get 0.707 is equals to 1 plus VGS by 6. 1 it will come and it will come around VGS is equals to minus 1.76 volts. Check it this one. Okay, after this you have to solve and tell me is this answer is correct or not.
So 1.76.
Yes, it will come like that.
So, but why negative sign should be positive, right?
You check it, I think it should be negative, right? When you bring this one this side, it will be minus of something and then you multiply it will minus, no? Check it. It's minus minus become plus.
Yes, sir. Yes,
This,
sir. Yes.
so it will be negative. Now you see the second question from here. For example, they have given one circuit, right, like this. And here they have given the value of RD. RD they have given as 560 ohms. And here they are applying the value of VDD like this. They said that this is the JFET where the value of VGS offset or VP is equals to minus 4 volts. Okay, you can assume this is VP. And they also gave us the value of ID SS is equals to 12 milliamps. They said that determine the minimum value, determine the minimum value of VDD required to put the device in constant current region. Constant current region of operation. Operation. So first read the question, what they are saying. They have given one JFET to us. They said the value of the drain resistance is 560 ohms. Okay. They didn't told us anything about VDD. They gave only the pinch off voltage minus 4 volt, and they also gave the drain to source saturation current to 12 milliamps. They are asking determine the value, minimum value of VDD so that you can put the device in a constant current region. If you remember your characteristic, it's look like this. This is the constant current region, right? And they are asking the minimum value of VDD, this minimum value of VDD, so that it can go in the saturation region. Saturation region where the constant where the current is constant, right? So as you remember, the minimum value that VDS in the case of constant current, VDS will be equals to VP, pinch of voltage. Then only you will get, and its value is 4 volt, right? Now, the value of ID will be equals to IDSS. Why? Because IDSS. Why? Because the formula, as you know, it is 1 minus VGS by VP whole square, right? And in case of the constant, in case of constant current region, VGS is equals to 0. Okay, VGS is equals to 0. Then what will happen? As this value is 0, you will get ID is equals to IDSS. And that will be equals to 12 milliamps. That is given in the question, right? IDSS is given. So its value of ID will be equals to 12 milliamps. Now, this value of VDD will be equals to VDS plus IDRD, right? See, this is if you apply the loop here, right? The VDD, here the current is ID, okay? And here the drain to source voltage. So if you apply here, you will get VDD is equals to, from here if you apply it, so VDD is equals to VDS, right? Sorry, here if you apply it, you will get VDD equals to VDS plus IDRD, right? If you apply it here, as you can see, VDD, IDRD, and the voltage drop across the drain to source, that is VDS. So you will get this formula. Now you know the value of, you have to find out the value of VDD, and you know the value of VDS. VDS is what? Pinch of voltage that we have already calculated is 4 volt. So you can substitute it here, that is 4 volt. You know the value of ID, that is 12 milliamps, and RD is also given in the numerical, that is 560 ohms. So if you substitute it here, that is 560 ohms, tell me the value that you will get from here. That is the value of VDD. This is the value of VDD to make the VDS is equals to VP, or the pinch of voltage. It's what?
10.7.
Yes, 10.7. Yes, 10.7 volts. Okay, so this is the answer. Okay, you can solve it numerical. I'm giving you the concepts. Okay, so now you see the different types of circuits so that you can solve more questions. Now you see we have one circuit like this.
Sir,
Yes.
Sorry, in the last question, can you say why VDS is equal to VP? Like, can you just explain that part again?
See, what is happening here? In this case, the minimum for the minimum value of VDS for the JFET is for the constant current reason is when your VDS is equals to the pinch of voltage. If you remember, this is a minimum value. Okay. If you see the characteristic, from the characteristic also it's clear that when VGS is equals to VD, then only that will go in the constant current reason. So you can see the lecture of that characteristic. In that, it is there why in the constant current reason the VDS is equals to.
Okay, so from the graph you've inferred
Yes,
this.
yes, yes.
Okay, okay. Thank you, sir.
So here,
Sir, also in the
yes.
same question, it was given as -4, right? Why did we take it as 4?
See, for the value of VDS, VDS is always positive, okay, and the VGS is negative. That we are assuming, right? If you remember, in the circuit, pinch of voltage is same for both, but problem is there when you are considering the VGS, it should be negative. Then only it will go in the depletion region. In case of JFET, okay, in JFET can work only in the depletion region. It cannot work in the enhancement mode. Okay, so when you are considering the value of VGS, it should be negative. Okay, and when you are considering the value of VDS, it should be positive.
Okay,
Understood?
sir. Yes, sir.
Okay. So now you see we have one circuit here like VDD, and they have given that the VGS offset is -6 volts, and IDSS is given 3 milliamps. Okay, and here VGS is also given to us is 2 volt. As you know, it's negative, right? You have to consider VGS is equals to negative. So they will give directly VGS is equals to 2 volt. But here you have to consider VGS is equals to -2 volt. You can see the direction of battery also. Okay, direction of the voltage source. And they said find out the value of ID. How we will find out? Tell me the formula that we can apply here. The same formula, right? The value of ID is equals to IDSS 1 minus VGS divided by VP whole square. Now you substitute the values. What is the value of IDSS? You tell me. Tell me what is the value of IDSS? 3 milliamps. 1 minus VGS. As I told you, they have given only the this figure. Okay, from this figure you can see VGS is equals to 2 volts, but because of the sign of the battery, you have to consider -2 volts. It's -2. VP, or you can say VGS is -6 volts. You can assume -6 volts like that. You tell me the value after this. So it's 3 milli will be there, 1 minus 1 by 3. Yes, minus will be there, minus whole square, and it is 10 raised to power -3. Like that, you saw. It is in the amps.
$1.3 million.
Yes, 1.33 milliamps is the answer. Okay. Now you see the next question. They said that reverse gate voltage of 15 volt is applied in the JFET. Okay. And the gate current IG is 10 raised to power -3 microampere. They said find out the resistance between gate and source. Okay, so how we will first you read the question. They said the reverse gate voltage of 15 volt is applied in the JFET. So they are saying the gate voltage right? That means a VGS. Reverse, that means minus, right? It will be a minus sign. Now, this is the gate voltage, that is the VG, that is 15 volts. Okay, and 15 volts of reverse gate they have connected. The resist, and then for finding out the resistance between the gate to source, how we will find out the resistance between gate to source? You can say it's VGS divided by IG, or the gate current. Okay, it will be 15 volts divided by 10 raised to power minus 3 into 10 raised to power minus 6. So it will be 15 into 10 raised to power 9 ohms. The resistance cannot be negative. Okay, resistance cannot be negative, will always be positive. You can say mod of it, you can find out, right? Mod of it. So you will get this value. Resistance cannot be negative. The direction of current will be there, the voltage can be negative, but the resistance will always be positive. Now, the next question, which is possible from here, they said when VGS changes from 3.1 volt to minus 3 volts. The VGS is changing from minus 3.1 volt to minus 3 volt. In the same condition, the ID is also changing from 1 milliamps to 1.3 milliamps. They said find out the value of transconductance. This is the new word for you, right? Transconductance. Transconductance for the case of JFET is denoted by the change in the drain current divided by the change in VGS. That means if you are changing the input, what variation you are getting in the output current is the transconductance. It's just reciprocal to your resistance, you can say. Because resistance is VGS by ID, it's a change in the drain current by the change in the input VGS. You have the value of ID. So how you will find out the change? For the change, subtract, right? 1.3 minus 1 divide by change in the VGS. Subtract from here to here. What is the change? 3.1 minus 3. Anyway, you can subtract it. Okay, we want only the difference. But the difference here is 0.3 and the difference between them is 0.1. Right? And here was milliamps, right? So it's milliamps. So it will give you a value 3 milliamps per volt, right? This milliamps and this is volts. So the transconductance that is given as GM. Transconductance is given by the symbol GM. Okay, so you can find out the transconductance by the you can assume this is reciprocal of what? Resistance, transconductance. Okay, so the change in the current divided by the change in the voltage. Change in the output current because of the change in the input voltage. Okay, so as you know, the formula for ID is equals to what? IDSS 1 minus VGS by VP whole square, right? So if you want to find out the transconductance, so the formula will be equals to GM is equals to GM offset 1 minus VGS by VP, or it will be equals to GM naught 1 minus VGS divided by VGS offset. Here square is not there. Okay, remember, in the case of the drain current formula, we was having the square. In the case of transconductance, we don't have a square here. Okay, that is the basic difference, and the rest is same. Just like here we have ID, here we have IDSS, here we have a GM, and this is the offset, right? So for this, we have one question based on the transconductance. They said that GMO, that is the offset, they directly gave us 400 microseconds. Okay, and they said that find out the value of GM where at VGS is equals to -3 volts and VGS offset or pinch of voltage is -8 volt. Can you tell me the value of GM? Apply in this formula. Okay, apply in this formula and tell me the answer.
Sir,
Yes,
sir, could you repeat what is GM basically, sir?
basically it's a transconductance. That means change if you're changing your input. Okay, what change you are getting in the output current, changing in the input voltage, what change you are getting in the output current. It's a transconductance. So its formula is what? The rate of change of ID because of the change of because in the change in the input voltage. Okay.
So can
Yes,
you
sir.
scroll down?
What? See, you are applying VGS. Okay. If you are changing this input voltage, there definitely there will be change in the ID here. So this is the property by which you are measuring the change in the drain current if you are changing your input voltage. So this is the transfer. Now you see, apply this formula, what you are getting, tell me. GM you have to find out.
Microsecond.
What answer is what?
The 2500 microsecond.
Yes, 2500 microseconds. So the GM will be equals to GMO, that is 4000 microseconds, 1 minus -3 divided by -8, and that will give you 25 microseconds, right? Now you will get some question like this also. Next question.
Sir,
Yes.
sir, the unit of GM is ampere per volt, right?
Unit of yes, ampere. Yes, ampere per volt. You can assume ampere per volt. Ampere per volt.
Oh.
Yes.
Okay, sir.
Okay, so now next question, when they have given one circuit for us. What is this? This like a JFET. Here -5 volts RG 1 mega ohm. RD is equals to 2.2 kilo ohms. And this is, for example, a 10 volts. Okay. Okay, so here we have one capacitor. First, I am explaining this circuit. Okay. What they are saying in the VGS offset is also given to us is -8 volt. IDSS is 16 milliamps. They said find out the value of VGS, ID, and VDS. From this circuit, we have to find out these three things. And in this circuit, they gave these values. What are these capacitors? These are the capacitors. This is called as the coupling capacitors. Coupling capacitors. What they do, they only allow the AC components and stop the DC from it. Okay. When we will go for the amplifier, that point I will explain the working of this complete coupling capacitor, and we are having a bypass capacitor also. In the next topic after this, we have an amplifier. There I will explain the use of these capacitors. Okay, so here they are saying, since the drain current, they are saying this gate current is 0. Okay, there is no flow of current here. IG is equals to 0. If there is no current, for example, if there is no current here, So what will happen? This value of VG, which is actually the gate voltage, will be equals to VGS, because there is no voltage drop here because there is no current. As there is no current, the value of VGS will be equals to VGG, and which is equals to -5 volt. So they have given directly the VGS value to us. If you know the value of VGS, if you know the value of VGS offset, if you know the value of IDSS, we can apply and find out the value of ID. So VGS, that was the first part that we calculated. And the second is what? ID is equals to IDSS 1 minus
Sir.
VGS by VP whole square. Yes.
So how is IG 0?
Actually, they in the question only they have given, because here in the question they have given the gate current is zero, is given. Okay, they have given that the gate current is 0. So if gate current is 0, definitely there is no current flowing in this one. So if there is no voltage drop, means current, there will no voltage drop across these resistance. So directly whatever you are providing here, you are getting across this gate to source. That's why this VGS is equals to VGG. Okay.
Yes, sir.
Now you apply it here, these formula, in the formula you apply these values. IDSS is 16 milliamps, 1 minus VGS is -5, VP is given to us, that is VGS offset, that is -8 volts. This -8 volts whole square. What you will get?
The 2.25 milliampere.
Yes, it's 2.25 milliamps. Okay. Now you see how to apply the loop here. As we have to find out the value of VDS. VDS, this is your drain, this is your source, right? The voltage drop across this one will be VDS. Okay. So if I apply the loop here, I'm changing the color so it will be good. See, I am applying the loop here from top to bottom. Okay. While considering the DC analysis, you just skip this capacitor. Don't bother about it. Okay. So when you are applying the loop here, what you will get? The value of VDD is equals to VDS plus IDRD. Right? This is the VDD. VDD is equals to VDS and IDRD. The drain current is flowing here. Okay, so ID into RD plus VDS will be equals to the source voltage, that is VDD. VDD is equals to IDRD plus VDS. Okay, so I'm writing the same formula here. VDD is equals to VDS plus IDRD. You know the value of ID, right? We have and we know the value of VDD. What is the VDD value? It's 10 volts. VDS we have to find out, plus ID we calculated is 2.25 into 10 raised to power -3, and RD is what? 2.2 kilowatt. So it's 2.2 into 10 raised to power. Now tell me the VDS from here, from this equation. Only a single unknown is there, so you can find out its value.
Five point zero five.
Okay, 5.05. Okay. So this is one type of the circuit. Okay, I will tell you the some different circuits here. Okay. Next question is similar to this one. For example, you have a circuit like this. Don't bother about these capacitors. This is used when we will go for the amplifier and analysis. Okay. They said the value of RS is 200 ohms. Okay. The value of RD is 5 kilo ohm. And the value of VDD is equals to 30 volts. The drain current that is flowing here is 2.5 milliamps. They said find out the value of VDS and VGS. VDS and VGS. So VGS, right? So how we will find out? By applying the loop here. Okay. So now first you apply the loop from top to bottom. I'm just changing the color. Okay. So now you apply it. As I told you, VDD is equals to VDS plus, if you apply the loop from top to bottom, okay, so VDD is equals to IDRD. VDD is equals to IDRD. Then you will get the voltage drop across this one, that is the VDS. Then the same current is flowing here, that is ID. So plus ID into RS. Understand? From this is the source voltage VDD. The current is same ID as these are connected in series, right? So ID into RD, then there is a voltage drop across drain to source, then there is a resistance, that is RS, but as there is a same current flowing, it will be ID into RS, right? So we know the values, like 30 volt is this one. We have to calculate the value of VDS plus ID is given to us is 2.5 into 10 raised to power minus 3. RD and RS is also known to us. You can take common ID and you can apply here 5 kilo ohm, 5 kilo into 10 raised to power 3 plus 200. Tell me the value of VDS for here.
Is it 17 volts?
Is 70 volts, yes. Now we have to find out the value of VGS. Okay, so the voltage which is across this one, VGS. So this is negative positive like that, right? It's negative positive. So if you apply the loop here in this loop, right? This closed loop. So you will get VGS plus ID RS because the drain current is flowing here. Okay, equals to 0. If you apply it here in this loop, you will get VGS plus ID RS. So that will be equals to VGS is equals to minus ID RS. You know the value of ID. ID is 2.5 milliamps. So it will be 2.5 into 10 raised to power minus 3. And RS is 200. So you substitute it here and tell me the answer. I applied the loop only, okay? From here top to bottom one loop and another one loop here. You can apply, as you know, if you are having the circuit like this, you can apply loop here, you can apply loop here, you can also apply the loop here, right? So tell
So
me the
how
answer.
polarity in VGS?
VGS is always negative. As I told you in the JFET, only depletion mode is possible.
Yeah, sir.
Okay.
So we take it as positive to negative.
Yes. Tell me the value here.
Minus 0.5.
It is minus 0.5. Now, next circuit is very important. Okay, so whatever I'm going to tell you is very important topic, or you can say important point. What is the meaning of biasing? Biasing means what? External voltage supply. How you are providing your external voltage. Okay, that is the meaning of biasing. One biasing is called as the voltage divider biasing. Voltage divider biasing. Okay, so what is this meaning of this voltage divider? If you are having one transistors like this, okay, here, as you know, this is a drain. For example, this is a drain, and the value of IRD is given to us is suppose 3.3 kilo ohm. One resistance in the source terminal, this is our source RS, okay, and the value of RS they have given suppose 1.8 kilo ohms. For providing the external voltage, what actually I am doing, I am giving one resistance like this, another resistance like this. It is called as the voltage divider biasing. Okay, that means, for example, if you are applying the 12 volt here, okay, and suppose one resistance is here like R1 is equals to 6.8 mega ohms, and here they are giving 1 mega ohms. This is R2. If you remember, if you are having the resistance like this and you are applying suppose here 12 volt, okay, 12 volt, and here you have a 6.8 mega ohm, and here you have a 1 mega ohm resistance. So the current is same because they are connected in series. But what will happen if I ask you the voltage drop across this one and the voltage drop across this one? Is it's the voltage drop will be same or different? First you tell me. The voltage drop across this volt resistance and this resistance are same or different?
Different, sir.
Different, right? So if I say it is a 12 volt, can you tell me the voltage drop across this resistance? You know the formula, right? What is this? Tell me the
V out.
12. Yes. V out is equals to,
V in.
yes, if it is suppose R1 and this is R2. And I am asking, okay, don't you tell me the voltage drop across this R2. So V out will be equals to V in. Then
R2 upon R1 plus R2.
yes, R2 upon R1 plus R2. Right? So this voltage drop or this voltage will be our the input voltage. Okay, so this biasing where we are dividing the voltages because of the series resistance is called as the voltage divider circuit. So for the such cases, how we will find out the value? For
Could you
example,
again?
what?
So could you please explain this again?
Okay, for providing the voltage in the circuit, we can give the biasing means what? Providing the external input. Okay, as a voltage source. Okay. So if suppose in the input part, we are giving series resistance like this, so the voltage drop will be different, right? So if you are dividing the voltage drop or voltage is called as the voltage divider circuit, because if you can see we have one resistance, second resistance connected in series. So I'm not explaining here, I just brought it here. 6.8 mega ohm and 1 mega ohm is connected in series, and one voltage that is 12 volt is connected like this. So what will happen if I ask you to find out the voltage drop across R2? Because as they are connected in series, the voltage drop will be different, right? So you can find out the voltage drop across the R2, across R2, across R2. What will happen? R2 divided by R1 plus R2. Understand? So here you can find out the value, right? Now in the question, for example, they have given the value of the drain voltage. Drain voltage they have given 7 volt. That means they have given VD is equals to 7 volt. So if you apply the loop here, for example, because we know the value of VD, okay, so it will be equals to VDD equals to VDS or VD plus IDRD. right? If you apply it here, 12 volt, right? And this is the voltage drop here, and this is the ID, if ID current is flowing here. So VDD equals to IDRD plus VD, right? So from here, either you can consider VDS because I'm not taking as this one. So you can take as a VD because VD is given in the numerical. It's a voltage drop only in the drain, not in the drain to source. Okay, so this is the drain voltage only. So from here, you can find out the value of ID. VDD is given to us is 12 volt. VD is also known to us is 7 plus ID is given to us. No, we have to find out the value of ID. RD is given to us is 3.3 kilo ohm. This is RD, right? So I'm applying the loop in this one. So can you tell me the value of ID from here? It is 1.52 milliamps. This is the drain current that we calculated. Okay, and we have to find out the value of VGS, right? We have to find out the value of VGS, which is equals to VG minus VS. In this question, we have to find out the gate to source voltage. Gate to source voltage you can calculate by the difference in the gate voltage minus the source voltage. So now for the source voltage, we have the value of ID. How we will find out the value of Vs? So here, the same current will flow, that is ID. So from here, if you multiply it, you will get the value of Vs, right? Vs is equals to ID into Rs. So the value of Vs will be equals to ID into Rs. That is equals to 1.52 milliamps into Rs. Rs is 1.8 kilo ohms. So tell me the value of Vs. It is, tell me the value of Vs. 2.7. Okay, 2.7 volts. So now we have Vs, but we have to calculate the value of what? VGS. VGS is equals to VG minus Vs. Now this voltage divider circuit will come into existence. I'm just changing the color and I'm explaining the role of this voltage divider. Okay, now we know the value of VD. VD is already given in the numerical. We also calculated the value of Vs. Now the problem is with the VG. How we will find out the value of VG? Because here we are using the voltage divider circuit. So for this, you can find out the voltage across R2 will be the VG. Okay, so the voltage drop across R2 will be your VG. So as you have seen, the value of VG is a volt in the voltage divider circuit. This is the total voltage VD. Just like here I explained, 12 volt is what is the voltage drop across 1 ohm resistor. So the same process you have to apply here. The VDD R2 divided by R1 plus R2. So it is 12 volt given 1 mega, in that means 10 raised to power 6, and then 1 plus what was the value? 6.8, right? So 6.8 mega, 10 raised to power 6. So tell me the value of VG. It is equals to 1 divided by 7.8 into 12. 1.53. 1.53. Now we have the value of VG, we have the value of VS, right? So can you tell me the value of VGS? VGS is equals to VG minus VS. VG is 1.53 and the VS is 2.7. So it will give us minus 1.53. What is the value of it? Tell me. 1.16 volts. This is the VGS, and this is the data. Okay. So once again, I'm repeating this process because this is more important than others. This is a important question based on the biasing. Biasing means providing the external. How we will provide the external input with the help of certain circuit. Okay. So first one is the voltage divider biasing, where we are using the voltage division rule. Okay, for providing the input. So how we will do? What is the voltage drop across R2 will be your VG, which is example. Okay, so you have to apply the voltage divider rule here, and for finding out the value of VD and VS, you can apply the loop. Okay, as we have calculated one loop, you have to apply here. Second loop you can apply here and tell me the value of VS and your VD. And after that, if you know the value of VG, you can find out VGS, you can find out VDS and all. Right? Now we will go this. Okay, so we will start. Yes.
So for finding out VG, why is R1 not affecting it, so only R2?
No, it's affecting because R1 is there, right?
Okay. So
Now we will see one question based on the DC load line, right? So we have one question like this. This is RD is equals to suppose 500 ohm, and here they are giving the value of VDD is equals to 20 volts, right? And here we are connecting some with some capacitors. As I told you, I will explain the role of these coupling capacitors and all. And we have a VGG here, that is VGG. This is ground, and connecting with this. VDD is 20 volt they have given, RD they have given 500 ohms. And they said draw the DC load line. Question is what? Draw DC load line. Okay, so as if you remember, the DC load line is what? In case of BJT, it was ID, and we have taken the value of voltage across the collector and terminal, right? Here you have to take the VDS and draw the line like this. That means this value will be what? VDD. VDD. And this value will be the maximum value of ID max, you can say. Right? So in the question, they have directly given the value of VDD, which is equals to VDS. I'm talking about the DC load line. That means you have to find out the I max, right? When your VDS is equals to 0. That means VDS is equals to 0. What is the value, right? And what is the value of your current? What is the value of your voltage when current is 0? Like that, right? So now the maximum VDS is equals to VDD for the DC load line. So VDD is given in the question, that is 20 volts. Okay. And for finding out the value of ID, maximum ID, ID, yes. What happened? Hello. So the maximum ID will be equal to VDD divided by RD. So this is the formula. Okay. You have to use this formula to find out the DC load line. DC load line is drawn between the ID and VDS, okay, where we have to find out the maximum value of the drain current and the maximum value of the VDS. So VDS maximum will be VDD and maximum ID will be equals to VDD by RD. So it's 20 divided by RD is 500 ohm. Tell me the value of maximum current ID. Tell me the value. Anyone?
0.04.
Yes, 0.04 amps. Okay, so we have seen some question, and now from next class we will see the amplifier parts along with numericals. Okay, again for the this PAT exam you have CAT exam you have CAT. So in that you will get numerical part, basically numerical part. So we are focusing on this only. So we will see the amplifier as theoretical, and then we will start the numerical based on it for your CAT exam. Right? Okay, that's all for today's lecture. If you have any doubts, you can ask.
Sir, what is CAT2 question?
CAT2 question will be based on MOSFET, FET, BJT, and we have a binary number system and basic logic gates. So that we will see. In the next lecture, we will complete amplifiers part. Amplifier is again related with your BJT and your FET. Okay. So that we will see amplifier. Then we have a oscillator part. Oscillator. So in the next lecture, we will complete amplifier along with the numerical. And then in next, we will see the oscillator part. That is LC circuit and the RC circuit. And then we have logic gates and universal gates. Okay, so the three parts we have. So then we will see the logic gates. So in the next lecture, we will try
Okay.
to complete amplifiers.
Yes, sir.
Thank you. I will take attendance directly from here. And again, if you have any doubt, you can.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay,
you,
I'm
sir.
sharing this notes for you.